It will be a quick tutorial on loadable kernel module of the Linux operating system. We talked about the various architectures of operating system. Linux is considered to be monolithic, but it also has modular functionality. One of the ways that Linux is modular is because of this loadable kernel modules. Essentially it is that whatever functionality you require in kernel, only that functionality you need to load, you can load, and you can also remove that functionality when it is no longer required. So let's go through this example quickly. Let's go to CD. CD means the current directory, and let's create our own folder here, LKM, CD LKM. So now we have taken an empty directory here. This directory does not contain anything. Then we have to, as the next step, we have to run this git command. And what does it do? It clones from this website. So if you go here and click, you can directly see that it actually is a website where it gives the details of all the chapters, all the practical examples that are given in the book. In our case, we are interested in chapter 2, and chapter 2 contains what we require. Okay, so you can just visit this website directly also. But in order to download, because it's a Git repository, you can simply execute this command. So let's copy this and execute it on a terminal. Once you have executed it, you can see that it has downloaded something. You can go to this operating system concepts10 edition folder, and inside that we are interested in chapter number 2, which is our current chapter. In this chapter number 2, you can see that there is a makefile, or this is a way to simply compile a kernel module. This makefile does it. Okay, and this simple.c, let's read through the simple.c. Simple.c is a C file, and what does it do? It is a simple kernel module. What does the simple.c do? In this particular case, it is just going to print that it has loaded the module once the module is loaded, and after this loadable kernel module is unloaded, this message will be printed, removing module. So let's try this now. In order to create a loadable kernel module, in this case, we'll have to just execute the make command. If you go through this make command, you will see that it uses a directory, and this directory you can see is user src linux headers 5 something generic. The question is, why is it actually entering this directory? The reason why it's entering this folder, this system folder, is because of this architecture. So in order to figure out the architecture, you have to type the command uname -r, and it tells you the kernel version, and you can clearly see that the kernel version 5.8.0-50 generic is the same one as this guy. So if you actually go into this folder, this headers folder, and if you go through this, you will see that it gives you a detail of everything that is required to actually build the kernel module. And now, in order to create the kernel object, you will have to simply type make and type enter. Now after this process is over, a lot many files are created here, but we are actually interested in this file, simple.ko. Now this ko here stands for kernel object. So you can use the file command to verify that it's actually a kernel object. It says simple.ko is actually a relocatable object, a kernel object that can be loaded into the kernel of the operating system. And we did a make, and the moment you do a make, a simple.ko file has been created. Now, in order to really verify that this kernel module is actually loaded as a module in the kernel, let's run some commands. In order to inspect how many kernel modules are right now, loadable kernel modules are right now running in your Linux operating system, the command is list modules. And the moment you hit list modules, it gives you a list of so many kernel modules. Some of the kernel modules seem familiar. XT-TCP UDP is the kernel module that is related to the transport layer protocol of computer networks. Some things like Bluetooth is obviously clear. Now, one way to check how many modules are there is to just run this command ls-mod wc minus l. And we can see that at this point 157 modules, kernel modules are there. Okay. And when we load our kernel module simple.o, it should become 158. Now if we go to this simple.c and look at the function that is invoked during initialization, it does not do a printf, but it does a print k. And remember that print k stands for print to kernel buffer. This is not printf where it prints to a file or std out. Instead, it prints to a kernel ring buffer. Okay. So all the functions that we have here, simple exit and simple init, they do printing only on kernel ring buffer. And in order to access this kernel ring buffer, the command is dmessage. The moment you hit dmessage and look at the listing of this, it will start with all the events that have happened, the systems that are being loaded, any messages that are coming from kernel, all of this will be directly loaded into the system. So at this point, we are really interested in making sure that this kernel buffer is empty. Okay, in order to do this, in order to empty the kernel buffer, let's run the command sudo dmessage -c. Okay, the moment you give your password, now if you run this dmessage, then there are no more messages. The kernel ring buffer has been emptied, so that we are now able to load this simple kernel module. Now go back to the PDF file here and you can run this command directly. It says sudo insert module simple.ko. So let's copy this guy and put it here. So now let's look at this command. INS definitely stands for insert, MOD stands for module. So basically we are asking the kernel to load this extra loadable kernel module, which doesn't do anything by the way. So now let's hit enter, and now as we will just see, the kernel has actually loaded this simple kernel module. How do you verify that it is actually loaded this simple kernel module? For this we will simply repeat the command here. Earlier there were 157 modules, now we run this command, it should become 158. This is the first check to verify that we actually have this simple kernel module. Now if you do an ls-mod and grep simple, then you can see that simple is a kernel module that has already been loaded. Okay, so ls-mod wc-l gives you the number of modules that are being loaded. Earlier it was 157 before our loading, now it is 158. This means a new kernel module has been loaded. And what is the kernel module that is loaded? Simple is the kernel module that is loaded. Now what does simple do? We know that it will just print the message loading module. But in order to verify this, let's run the dmessage command, and the moment we hit the dmessage command, it says that at this point in time, okay, it issues this loading module command. Now in order to remove this module, remember it's loadable kernel module, this means you have an option of unloading it after the task is over. So you can do sudo rmmod simple, and the moment you hit this, you now run this ls-mod wc-l command, and you can see that the number of modules have now become 157. Similarly, if you ls-mod grep simple, then you will see that no output is found. Earlier when we ran this command, we saw that simple was a kernel module, but now when we run it, we don't see it anymore. This means it has been unloaded. And finally, to verify, we can print the message from the kernel ring buffer. And whenever you run this dmessage, it says it is loading a module at this point in time, and after some time it has removed the loadable kernel module.